Blessed day to all. Welcome to my channel, Math with Mrs. O. I'm Ofelia Orate, a principal owner of a school and a tutorial center, a math teacher and an author of 21 books. Before we start, please smash the subscribe button and the bell button so we can notify you on our next videos. Our lesson for today is linear equations in two variables, which we will just call later as LETV, linear equation two variables, or linear functions. What is the difference between the two? Okay, they're practically the same. When you say linear functions, you're referring to your f of x. Your algebra is a little higher. Your f of x is simply your y equals mx plus b. You can even change this to a, and then you can change this to c. These are just variables, where m and b are constants. Now, if you are in simple algebra, let's call it simple algebra, you call it as linear equation in two variables. So it is now an equation which can be written in the form ax plus by plus c equals 0. Your a, b, c here are elements of any real numbers, and of course, a and b cannot be 0. What happens if a and b are 0? If a and b are 0, this becomes 0, this is 0, you now have c, a constant which is equal to 0. That is not right, that is incorrect. That is why you have here restrictions. Now let's proceed. Which are LETV? Which are linear equations in two variables? Number one, is it? Yes. Y. As you can see, you can write it in the form ax plus by plus c. Transpose this, it becomes plus c equals 0. So the answer is yes. Number two, can I write it in the form ax plus by plus c equals 0? Yes. This is your ax, transpose that, plus by plus c equals 0. So the answer is yes. This becomes your a. Just to be clear. Now, what about x equals 8? Still yes. The question is, Mom, how is that a linear equation in two variables where I only have one variable here? In the Cartesian plane, when we graph this, you will see that you will still have a line. And here, it is understood that y is an element of the set of real numbers. We will explain that once we move on to graphing. What about number 4? The answer is still yes. Now your question again, same as in number 3. It is only involving one variable. How can it be LETV, where t means two variables? In the Cartesian plane, or under the Cartesian coordinate system, you will have an x and a y, and here it is understood that x is an element of R. Number 5, is it? Look at the forms, mx plus b, ax plus by plus c equals 0. The highest exponent of x and y is 1. You have an exponent 2 here. It is not linear. So the answer is no. Not a linear equation in two variables. Of course, number 16 obviously is no. And then number 7, look at number 7. Your x is in the denominator. Take note, you have learned that 1 over x is equal to x to the negative 1. You have a negative 1 exponent, so obviously this is no. Now, let's move on to letter B. You sketch the graph of y equals 3x plus 2. Always remember that that the graph of a linear equation in two variables is a set of points that lie on a line. Remember, the root word here is the word line. Line. So if it is linear, when you graph it, you will have a line. So, how do you graph this? There are actually different ways. The first, simplest way is to find two ordered pairs. So, you make a table, the values of x's are here. You substitute any value for x, y any value for x. Remember, your domain here is the set of real numbers. So you can substitute any real number here. And your range, of course, if you substitute any real number here, your range will also be any real number. In other words, if I substitute 1 to x, 3 times 1 is 3, plus 2 is 5, y is still a real number. Now, the question is, can I substitute any value of x here? Yes, the answer is yes, as you can see in the domain. But the best thing for you to do, so that you can take a shortcut, is to substitute small numbers like 0. 0 is my favorite number whenever I graph, because the value is small and I can easily get the value of y. And you can plot it. Now, what if you substitute here 1 million? You may, that is your choice, but what happens? 3 times 1 million will be 1 million plus 2. So how do you graph 1 million here? 1 million, 1 million, or 3 million, it will be so hard for you. So you better choose small numbers like 0, 1, negative 1, negative 2. So when x is 0, what happens? 3 times 0 is, let me do it step by step. When x is 0, y is 3x plus 2. So you have y is 3 times 0 plus 2, right? 3 times 0 is 0 plus 2 is 2. There. When x is 1, you can actually do it mentally if you want. So substitute 1 here, so 3 times 1 plus 2. 3 times 1 is 3, plus 2, that is 5. There. Now, the question is, Mamorate, is one ordered pair enough? The answer is no. I'll show you why. Let us plot this. 0, 2. When x is 0, this is your x-axis. Y is 2, let's say this is 1, 2. There, that is your point. Right? Back to the question. Is one ordered pair or one point enough to graph the line? The answer is no. Why? I'll show you. If this is your only point, ordered pair, or only point, you do not know where the line is going through. Will it be going there, 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 or there? See? There can be infinitely many lines that passes through one point. So the answer is no. Let me erase that again. What about two ordered pairs? What about two ordered pairs? Why did you stop here? Why did you stop and you did not continue? Because 2 points determine a line. You will learn this in geometry. 2 points determine a line, meaning the minimum number of points for you to draw a line is by using 2 points. So 2 ordered pairs are enough for you to draw the line. Okay, let's continue. 0, 2. 0, 2 is here, there. 1, 5. Let us say this is 1, 1, 2, 3, 4, 5. This is 5. So 1, 5 is here. There. As you can see, this is your line. See? 2 points determine a line. Now, let us say you have a question. Ma'am, what if I substituted -1? That's alright. So when x is -1, 3 times -1 is -3. Plus 2, let's try that. That's -1. Right? 3 times -1 is -3 plus 2. That is -1. Oh, let's plot this. -1, -1. -1 is here. Oh, this is, let's say, -1 is here. And -1 is also here. This is -1. So you see, -1, -1. The point will still be on the line. So even if you get other points here, set of points, which will give an ordered pair, for sure those other points will still be on the line. Let's move to the next example. In my third example, I'll show you how to sketch the graph of 3y minus 2x equals 4. But this time, we're going to use a different approach, which is by using the X-intercepts and the Y-intercepts. This is shorter than what we did here in letter B. Let me recall again. In letter B, we use 2 ordered pairs to plot the points and graph the line, because 2 points determine a line. You can substitute any values here, but make sure that to take a shortcut, you use small numbers like 0, 1, -1, 2, or -2. But always remember that 2 ordered pairs are enough for you to draw the sketch of the line or the graph of the line. Now, another method which is easier is for you to use the X-intercepts and the Y-intercept. The X-intercept is the value of x when y is 0. And the Y-intercept is the value of y when x is 0. Let me write that. X-intercept. This gives you the value of x when y is 0. So the Y-intercept is now the value of y when x is 0. This is the meaning algebraically. I'm going to give you another meaning geometrically later. Now, why is this easier? Because you're letting x be 0 immediately. When x is 0, there, so we have here 3y minus, of course, this becomes 0 equals 4. So 3y equals 4. Divide by 3. Y is 4/3 or 1 1/3. As you can see, I made sure that in my third example, you have a fraction so that you will also learn how to graph or how to plot a point where one coordinate or both coordinates are fractions. Now, for the Y-intercept, this is the Y-intercept, the value of y when x is 0. Right? So your Y-intercept here is now 1 1/3. Now let's move to the next. The value of x when y is 0. Make this 0. This time make this 0. So 3 times 0 is 0. Minus 2x is 4. Divide by -2 both sides. You see that x equals -2. There. So -2 is the X-intercept. Let me write it here to be clear. When y is 0, x is -2. There, we plot them. 0, 1.5. When x is 0, you have here 0. Let's say this is 1, this is 2. Somewhere here, 1 and 1/3 rather, 1 and 1/3. 0, 1 and 1/3. There, x is 0, y is 1 and 1/3. Remember, this is the y-axis and this is the x-axis. -2, 0. So when x is -2, say this is -1 and this is -2. -2, 0 will be somewhere here. There. You plot the points. You have here your line. Now, geometrically, you will see that your y-intercept, which is 1 and 1/3, geometrically is where the line intersects the y-axis. So this is your y-intercept. And what about the x-intercept? -2. As you can see here, this is where your line intersects the x-axis. There. So now you can see that it is easier if you use the x and the y-intercept to plot the line. Let's move to the fourth example. My last example here is a different one because you will have to graph a linear equation in two variables over the domain x is greater than or equal to -4 and less than 0. I'll give you a shortcut here immediately. If you're asked to graph a linear equation in two variables over the domain, then when you assign values for x and y, especially for x rather, you get this, the values at the end. You let x be -4 and you also let x be 0. Now, so when x is -4, we have here y minus x equals 3. Substitute the value of x. So y minus x, which is -4. So you have y minus -4 equals 3. Y plus 4 equals 3. So y gives us 3 minus 4 is -1 here. So we have one ordered pair, -4, -1. Remember, this is an ordered pair, -4, -1. Then we substitute x equals 0. So when x equals 0, we have there y is y minus x equals 3. So y minus 0 equals 3. So y is 3. So when x equals 0, y is 3. We learned that 2 points determine a line. So you don't need the other ordered pairs here. But if you want to, it's okay. You will get the same line. Now let's plot this. 1 first, 0, 3. When x is 0, you have it here. 1, 2, 3. 0, 3 point will be here. -4, -1. -1, -2, -3. Then let's say this is -4. There. -1 will be somewhere here. -4, -1 will be here. Now, take note. Greater than or equal to -4. There is an equal sign here. Therefore, -4 is included. So you shade this. Shade it. But here, this is less than 0. So you leave this unshaded. Connect this and then erase. Let's erase this instead of being shaded. This must be unshaded. This means that -4 is included or is on the line, while 3 here, since there's no equal sign here, is not included or is not a point on the line. There. So you now have a, what do you call this, line segment, or there, a line segment where 3 is excluded. There, that's how you graph a linear equation in 2 variables over a domain. Thank you. Before we end, let us always remember to add kindness, subtract, judgment, multiply, understanding equals Mrs. O's good life equation. Smash the subscribe button and hit the bell button. Don't forget. Thank you.